morning everyone. I am Tanushree Dalai from Civil Engineering branch. So in the last class, we discussed about some numericals based on flexure equation, or you can say bending equation. And today we will discuss some other kinds of numericals based on the same equation. So here is a problem, which is a beam is simply supported and carries a uniformly distributed load, which is 40 kN per meter, run over the whole span. The section of the beam is rectangular, having depth as 500 mm. If the maximum stress in the material of the beam is 120 Newton per mm square and moment of inertia of the section is 7 into 10 to the power 8 mm fourth, then what is the span of the beam? So here length or L of the span in the beam you have to find out. So first of all, in step 1 we have to write down what are the data givens. So first of all, the depth of the beam is given, which is 500 mm. The maximum stress value is given, which is 120 Newton per mm square. And I value is given, which is 7 into 10 to the power 8 mm fourth. And load is given, which is 40 kN per meter. So now, in step 2, we have to find out the moment, that is bending moment of the beam. So as you know that it is a simply supported beam and loading type is UDL. So the maximum bending moment for this case will be WL square by 8. So we know about W and we don't know about the L. So we can put the 40 in place of W, hence the value will be 40 into L square divided by 8. By simplifying this, we will get the value 5L square, which is the maximum bending moment for this problem. So in step 3, we can calculate or we can find out this L value by putting the equation of bending, that is M by I, is equal to sigma by Y. So we know that we can put in place of M 5L square and I value is given in the question. Sigma value is also given in the question, and due to it is a rectangular section, so we know that the Y value, that is the neutral axis, will lies on the half of the depth of the section. So depth of the section is 500 and 500 by 2, which is 250 mm. This is the value of Y for the rectangular section. Hence, by putting the value of Y here, we can find out the L value, that is the span of the beam, which is 8197.56 mm. So this is your answer. So now we will solve another problem, that is a square beam which dimension is 20 mm into 20 mm in section and 2 meter long is supported at the ends. That means the span of the beam is 2 meter. The beam fails when a point load of 400 Newton is applied at the center of the beam. What uniformly distributed load per meter length will break a cantilever of the same material 40 mm wide, 60 mm deep and 3 meter long? So now, first of all, we should write down the data givens in the step 1. So first of all, here two types of beam is there. First one is your simply supported beam and second one is your cantilever beam. But the material used for the beam is same. Hence we can say the stress value, that is the value of sigma, will be same for both the beams. So first of all, for the simply supported beam, the dimension of the beam is square type, which is 20 by 20, and the span of the beam is 2 meter, and here a point load is there which is 400 Newton at the center of the beam. And for the case 2, which is for the cantilever beam, the B value is given as 40 mm, the D value is given as 60 mm, and the length of the span of the beam is 3 meter. So now we will solve this question. So first of all, for the simply supported beam, we have to calculate the value of maximum bending moment for the solution. So as we know that in case of simply supported beam, while it is subjected to 1 point load at the midspan of the beam, the maximum bending moment will be occur at the center of the beam, which is WL by 4. So here is your formula. We know the value of W, we know the value of L. Hence, by putting this value, which is 400 into 2000 divided by 4, we will get the value of maximum bending moment for the simply supported beam, which is 200 into 10 to the power 3 Newton mm. So now we can find out the value of moment of inertia in step 3. So as we know that it is a square section, so the formula will be BDQ by 12. So B value is 220 and D value is 20. Hence 20 into 20 to the power q divided by 12, by which we will get the value of moment of inertia as 13333.33 mm4. So now we got the value of m, we got the value of I. So in step 4, we can calculate the value of sigma by putting the value of m, I and y. So as we know that it is a rectangular section, so here also the neutral axis lies at the half of the depth. So depth is equal to 20. So half of the depth is 10. And m value is 2 into 10 to the power 5. And I value we got 13333.33. And y value is 10. Hence, sigma value will be 150 Newton per mm square. Hence, we got the value of bending stress for the simply supported beam type. And now, for the case number 2, which is the type of beam is cantilever here, but the material used is same as the simply supported beam. So now, the sigma value will be same for the case 2. So for case 2, what are the data given? First of all, write down. So the length of the beam is given as 3 meter or 3000 mm. The width of the beam is given as 40 mm. The depth of the beam is given as 60 mm. And the type of the beam is cantilever. Then in next step, that is step 6, we can calculate the maximum bending moment value, as we know that it is a cantilever beam and the UDL is provided. So we know that whenever a cantilever beam subjected to UDL on the whole span, then the maximum bending moment will be occur at the fixed end of the beam, which is WL square by 2. Hence we know the value of L. So we can put the value of L here. So W into 3000 square divided by 2. So this is your maximum bending moment. Now we can find out the value of moment of inertia, as we know that it is a rectangular section. So we can put the value BDQ by 12 here. So B value is 40 and D value is 60. Hence the formula will be like 40 into 60 to the power 3 divided by 12. Hence we will get the value of moment of inertia as 72 into 10 to the power 4 mm to the power 4. And the last one, by which we can calculate the value of load for the cantilever beam. So by putting the equation of bending, that is M by I is equal to sigma by Y, we can find out the value of UDL for the cantilever beam type. So we know that the value of M will be W 3000 square divided by 2 and I value is 72 into 10 to the power 4 and Y value is 30. So now by putting this value, we got the value of W as 800 Newton per mm. And this is all about your numerical based on bending stress or flexure stress. So today this much. We will discuss some other thing regarding chapter 3 in the next class. Thank you.